is the Air Force Missile Test Center, Cape Canaveral, Florida, September 1957. These 4 launching sites are assigned to flight tests of the Atlas Intercontinental Ballistic Missile. Nearest the camera is Pad 14. Here, during September, 2 major tests were run on Atlas Missile number 6A, a static firing at main stage, and on 25 September, flight test. Except for this narration, all sound effects in this film are heard just as recorded at the time of the events. The ready room at lower right. A final briefing is held before each test. Each segment of the contractor's test team reports on his area of responsibility. The chief test conductor assures himself that all is in readiness on the test stand and that the bird itself is ready. Missile 6A. Here, separate components must function with absolute reliability. Everything must be checked before the missile is left alone on the stand. And it is the job of these engineers to remove the element of human error.
Personnel not needed in this operation will retire at this time to the ready room at blockhouse area.
As a final proving out of all interlocked systems, the missile was held down for a sustained main stage firing.
Ignition.
Missile 6A was static fired on Friday night, 20 September. Planned duration was 36 seconds. The engine timer cut the engines at 35 and 9/10 seconds. Data collected during this run showed all systems performing satisfactorily. The missile was ready for flight. On 25 September, the red ball at Cape Canaveral's north boundary went up to warn ships offshore that a launching was scheduled. The countdown was underway for the second Atlas flight. Even though every part of the missile had been completely checked, as completely as possible on the ground, only the added dimension of flight could prove actual performance. There were 1,768 items in the countdown procedure for 6A. This is one detail of hundreds in pre-flight preparations on the launching pad. Installation of the engine igniters. Meanwhile, at other installations spread out over the Cape, preparations were underway to support the test. This is the Azusa site. X and Y band antennas in the background are slave to the optical tracker for the first few seconds of missile flight. After tracking has started, the system locks on electronically, follows the flight trajectory automatically. A high-frequency radio beam is transmitted to the missile in flight. The airborne component of Azusa amplifies and retransmits the signal on a different carrier frequency. This provides frequency data by which the velocity and position of the missile can be determined. Also a part of the Azusa site is the impact predictor, which continuously relates the missile's flight path to its point of impact. Position and rate data are fed to an IBM brain, which charts its predictions on these scaled maps. A trace line indicates the point where the missile would fall should shut-off or destruct occur at any given moment. 1 mile from Pad 14, General Electric Guided Missile Control Facility number 1. For this test, the GE technicians were interested primarily in setting up procedures for checking performance of the jet test oscillator during flight. Purpose: to investigate flame attenuation interference with transmissions between the missile and ground stations. In later Atlas tests, this facility will be concerned with missile guidance. Inside Central Control, 9,000 feet from Atlas Pad 14, this is the sequential timer used to synchronize various support functions of the test range. In the control room, these vertical panels present a continuous plot of the missile's flight path compared to its planned trajectory. Here, range radar is added to the other tracking operations. The range safety officer's console is nearest the camera. Every component is rechecked for accuracy on flight day. The meteorological section provides current and predicted weather information. From camera and theodolite positions surrounding the launch area, optical measurement and a visual record of flight performance is provided by Radio Corporation of America as part of its space support contract. High-speed cameras at the pad provide a detailed record in milliseconds of the launching. All support activities are paced by the contractor team inside the blockhouse. These men are in direct control of all preparations for launching the missile. The test conductor's control console is in the foreground.
Attention, please. All engineers and technicians assigned to the standby crews, when they leave the complex, are to report to the east side of Little Cave. All engineers and technicians assigned to the standby crews report to the east side of Little Cave when you leave complex.
These consoles remotely control liquid oxygen, fuel, helium, and liquid nitrogen flow from storage tanks into the bird. All electrical and hydraulic pneumatic power to the entire complex can be controlled from these stations.
Attention, please. Personnel should evacuate the area at this time. All personnel not assigned to the blockhouse should leave the area at this time.
As part of their base support contract, Pan American Airways Security Police have the responsibility of clearing the danger area around Pad 14. Liquid oxygen supply pipes set up a distinctive wail as they are pre-cooled before LOX is fed to the bird.
status check. Azusa.
Azusa, go.
Govat.
Govat is go.
Beacon.
Beacon, go.
JPO. Range telemeter.
Still no go.
What is it? Has the deviation changed?
No deviation change.
This is satisfactory with Convair. We will proceed.
That's all right, Roger.
Telemeter and quality.
Otherwise, it's good.
Go. T-minus 3 minutes and counting.
Moving Army safety cam. Flying okay. Starting flight track. Flying 230. Fire. Water flow okay. Jumping LM2. Yes, okay, Carlos. Yes, sir. Okay. Minus 2 minutes. Good, John. Mark.
Desk off on, switch to on. On, light on.
Minus 130. Securing lock tanking. Minus 125.
Roger.
Switching missile to internal DC. Switching telemeter to launch condition. Minus 120.
Command on internal.
Roger.
Telemeter in launch condition.
Roger.
Missile on internal DC.
Roger.
Pressurization complete.
Roger.
T-minus 60 seconds and counting.
Range safety test selector switch to on.
Roger.
Locks red line. It's
Minus
okay. 50 seconds. Keep watching. Minus 45.
Fast safety ready. Range safety on, lights on.
Roger.
Range ready.
Range is ready.
Water system ready.
Ready.
Prep complete. Raw light is green. Lock tanking secured.
Roger.
All recorders dispatched. T-minus 27 seconds and counting.
Lock start tank pressurized.
Telegraph.
Roger. Minus 20. Minus 15. Still good, more than.
Come on, baby.
Minus 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. 0.
Come on, baby, go. Got everything, go.
Lift off.
Range safety officer detonated missile 6A 63 and 6/10 seconds after liftoff.
Plus 70.
Range safety just tore up.
Atlas Missile 6A was launched at 2:57 p.m. Eastern Standard Time. Ignition stage, thrust buildup, and transition from ground fueling to airborne fueling was routine. The launcher release operation duplicated the successful performance of the first flight missile. Total weight, 181,600 pounds. Total thrust, 265,400 pounds. The autopilot again successfully demonstrated its ability to hold the missile to its predetermined trajectory. Early in the flight, the system moved the thrust chambers minus 1.9 degrees in pitch and 0.4 degree in yaw to correct for a crosswind of 9 miles per hour. After 32.6 seconds of flight, there was a propulsion system failure. Thrust chamber pressure fell to approximately 35% of normal level for about 3 seconds, followed by a complete loss of thrust. Telemeter data indicated that this was caused by a helium line failure. This may have resulted from vibration, heat, or a combination of these two. Maximum altitude attained 16,300 feet. Velocity 450 miles per hour. Duration of flight from liftoff to destruct by the range safety officer, 63 and 6/10 seconds. During flight, information from 135 separate sources was telemetered to ground stations. Information on heat, vibration, pressure, and performance of all the interrelated systems in the missile. Out of the 135 measurements attempted, 131 were successfully recorded. Immediately following a test, all flight information is forwarded to the Data Reduction Laboratory at the contractor's San Diego plant. Here, the data is taken from magnetic tapes and translated into readable form. The subcarrier frequencies are played back and duplicated in the form of oscillographs, photooscillographs, and digital printouts. "14 days after flight test, all important information had been compiled in the flight test evaluation report. This book is the life story of Missile 6A. The information it contains is the basis for important design changes to Missile 10A. This third flight missile represents the next step forward in the expanding program of flight tests, backed up by a broad base of research and development on the Atlas weapon system.
Minus 30. Mark. Minus 20 seconds. Minus 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
How does it look? Roger, programming. Don't ground far off. Right down the middle. Right on line. You have an azimuth report. Right on line. An azimuth report. Right down the middle. Programming. What's azimuth look like, Cal? How's azimuth?
Plus 180.
As the first stage THOR accomplishes its assigned task, its rocket engine cuts off. Now, the second stage takes over. As progress of the flight is relayed to complex receiving instruments, the third stage firing is recorded. Human eyes can no longer contact the speeding missile. Neither can our most advanced cameras record the final stages of the flight on film. Other products of man's ingenuity must see for him by proxy. And man's electronic vision was passing the test. The lunar probe seemed to be right on course, headed for its lunar target. If all went well, 2.5 days later, the fourth stage would begin its orbit around the moon, sending to Earth the important information man needed so much. The first big reach into space was being made, and man was beginning to collect the data that the Pioneer was sending back to Earth. But not from the moon. Not this time. The Pioneer continued its upward surge, slightly off course and losing speed.